Hey guys, welcome to your YouTube channel where we talk all about the GATE exam and we are into the quick revision video series. So we are studying the operating system and in this video I'm going to revise you the process management unit number 2. So here are the brief things which we are going to quickly revise, and right after that we are going to solve some of the GATE questions which could be considered to be related to these topics. So yes, the very first thing which comes in mind when we say process management is what is process. So just to summarize it properly, I would say let's consider a process as a data structure and relate it to the four specifications, different specifications. So the very first specification of any data structure is what? What is its definition? What a process is? Correct? So what a process is, when we define a process, it very much gets connected to the program, because the active state of a program is nothing but then a process, right? So when you see the definition of the process, you should also keep in mind what are the differences between a process and a program. It's an active process, it's an active thing, it's a passive thing. It stays in the RAM. Once it gets activated, it comes into the RAM, it stays on the secondary memory. It has the different resources attached to it. It has no resource attached to it. Okay, we can have, for one program we can have multiple processes, for one program we can have one process. Like that, the correspondence between two should be very much clear. Then after, we could say what is the address space of a process. How does a process look like? When a process consumes space on your main memory, what is its representation like? What is its structure like? So if you just want to briefly understand this, right here, this is a process address space. Okay, so you all understand, for any process, because it's a program getting into execution mode, so it will have the code, instructions to get executed, and it will have the data, which could be a static data or the dynamic data. So here the different sections denote a different type of data. So I hope this part you keep in your mind, because this is very much, this part is not only here. If you go to the compiler construction, the compiler design chapter, the runtime environment, there also you need to understand this diagram. So the lowest addresses are consumed by the code or the text section where your instructions of the process are stored. Okay, and then after comes a stack, which will store all the static data, which will include your global variables as well as, right? It will be in the form of stack. After that, we have the space available towards the higher address allocations for the dynamic data in terms of heap. So whatever dynamic memory allocation your program or your process makes at the runtime, with the help of, supposedly in C, if I have to say, I would say with the help of kalloc and malloc function. So whatever dynamic memory allocation is done, it is done from the heap representation. So this part of the data is in the data structure form of heap. Alright, so this you can consider as this is used for the DMA, dynamic memory allocation, this part. Okay, now there comes the second last one. So you see, this is an empty part. It simply says this is dynamic and this is also dynamic. This will grow upward and this will grow downward. Okay, because it's a runtime thing, these both are dynamic structures and it will be working as per the execution of your process. So this is your runtime stack, which most of you would be knowing is used for the storage of the activation record. So whenever your process is running, any function call you make, you create its activation record and you store into the stack. So this is going to keep all the function parameters, the return value, the local variables, everything is going to get stored here. So I kind of elaborated your process address space, which is probably why, because it is also connected to the runtime environment in compiler design. So this is your process address space. For your revision part, you need to keep this in your mind. Alright, next, the operations, or we have done this part, this part. Now operations on process, we all know what are the operations on process or process states. Probably the operations of process itself get translated into various states, like creation of a process, then process will be in the ready state, it will be in the running mode when it is getting executed on the CPU, it might get suspended in between from the ready state to go in the secondary storage again, it might get resumed back, it might have to be blocked for the wait of an input output operation or some resource. It might be terminated, that is the resources are deallocated, and when it is created the resources are allocated. So likewise there are so many things which could be considered as operations on process, right? So this part is also done. Of course the process state transition diagram I'm going to take up in the next video. So you might find myself a little bit faster. Why? Because it's a revision. Okay, I'm not explaining anything, I'm just briefly going through all the pages of your notebook, right? So the next thing is attributes of a process. Every process have its own attributes, have its own values, distinct values which are related to it and which are very important for its execution. So a kernel or operating system will store the information about each process, or you can say attributes of each process, in a particular data structure which is known as a process control block, also known as task control block or the process descriptor, like this. So that is PCB. So each process is going to have its PCB, and it is very important when it comes to context switch, right? So whenever a context switch will happen, the PCB of the old process will be stored and the PCB of the new process will be resumed back, correct? So I have a picture of a PCB right here, where I have just put up few of the information, right? So each process will have its own process identification number, so PID. Each process will have its own program counter value. Wherever a process is running, whatever is the value of program counter which is showing the address of the next instruction to be executed will be here. Stack pointer. So all the important registers which are required for anything to be executed are owned by each process when it is into the running mode, correct? So that information will always get stored in its PCB. The register value, so whatever general purpose registers, special registers, whatever registers this process, specifically this process is using, their values will come up here. The scheduling information, as I'm again and again saying that it is a specific thing for each and every process. So if process 1 is getting scheduled over priority scheduling algorithm, so that information should be here, that what is the priority of this process, correct? Main memory unit information, how this process is going to get stored, what is the memory organization, what allocation you have used, are you using the paging or you're using the segmentation or you're using something else. So the page table information, segmentation table information, everything is to be stored somewhere, right? Then the miscellaneous data, whatever data is related to a process which is essential for its execution, for its identification, has to be stored in its PCB, correct? So this is what makes up the process quick revision, I believe so. So now let's do the question on the what we understood so far. So there is a question in the GATE 2000 which was asked about the process control block basically. So the question says, which of the following need not necessarily be saved on a context switch, mind it, context switch between processes. So when we do the context switch, as I just now told, that when we do context switch, we store the process control block of the older process and load the process control block of the newer process, correct? So it is about which of the following need not necessarily be saved. So we are storing the PCB of older one, right? So which is not necessary. It is asking during the context switch which of these given are not necessarily to be stored. Okay, so general purpose register, as I told, PCB as a whole is compulsory to be stored. Okay, so whatever is there on PCB is compulsory to be stored. So general purpose register, where do you find it? On the PCB. So is it compulsory or not? Yes, it is compulsory to be stored, right? Then transition look aside buffer, what is it? TLB, transition look aside buffer, which is part of cache memory which is utilized to store the part of the page table to find out the direct translation immediately right there. You don't have to come back to the page table and find it. To minimize the time of access, memory access time, we make use of this TLB. Is it necessary to be stored? Let's see. Program counter, definitely. Without having the information about the program counter, how would you know what is the next instruction? So yes, definitely. Then it says all of the above. Certainly not till we find out about the look aside buffer. So look aside buffer is nowhere on my process context block, okay, and this is of course not necessary for my execution of the next process. What is necessary for the execution of the process is the PCB values, which is this and this. Translation look aside buffer might get, you need not to store the translation look aside buffer, you have to invalidate the translation look aside buffer because it is representing the older process. Now the newer process has to get its own values. So it's not about storing and creating, it's about invalidating. So whatever was there, you just have to delete, might be, probably, but it is not about that. We are talking about what we are supposed to be stored. So this is the answer, that this is not necessary. TLB need not to be necessarily be stored. If it is getting done, that's another point, but it's not compulsory. It is not something which is an essential thing, without which execution will not happen. So answer is option number B. So I hope you understand how just now what we revised is right here in front of you as a question. And don't go away, there is one more question from the same part, which is GATE 99 question. I would like you guys to solve this question, and if at all you have any doubt, just post them down in the comment section. I will see you very soon in the next video.